Cool, we'll get started. So I'll give a little bit of an overview of how we use ClickHouse at Cami and how we came to use it. There's a bit of a journey of how we got there. It certainly wasn't the first solution we tried, but it was a solution we found that actually worked for us at the scale we're at. And also just how we came to collect data in-house in the first place. Why we did that versus just collecting data on Google Analytics or some sort of third-party solution. So why we do in-house tracking, how we evolved there, and how we ended up migrating to ClickHouse. So tracking events in-house really came down to the ownership we wanted to have over the data. Well, that was the primary reason. We started off, as many companies do, somebody's using our app, they're clicking around, they're loading up a document. We make a solution for schools, if you didn't know, so people are loading documents, they're making annotations, doing their work, and we started off tracking that in just sort of, Google Analytics, we used Mixpanel, things like that, and that was great, but we wanted to be able to own that data and be able to do analytics on it long term and really have a lot of control over that. So we decided we wanted to collect that data ourselves, and this was back in 2014, so actually over a decade ago now, which is kind of crazy, allowed us to do our own analytics and be very free form. We weren't limited to what query somebody else had built up in their tool, and it meant that we could control costs too, which became an issue later on. So we started off and we built this in really just about the simplest way we could, because at this time we had, I think, 2 engineers in the company, me and my co-founder. So it was literally just people are using our product. Okay, we'll send those events to our backend servers using Rails. We'll write that into our database, which was Postgres. We just created a new table in there called events, and said, okay, we'll write them into there. And then we had Redash, where we could write SQL queries and look at what events we attract. So the schema was like event, name of the event, actually a user ID as well, which I'll put on here, and then a big JSON field where we could put all sorts of freeform stuff to tell us about what this event was, and context and what thing they clicked on, and all of those kinds of details. To go back, so we would just write that into Postgres and we'd run queries on it. And this worked pretty well at first. We started off, when we did this, we didn't have that many users. It was pretty low volumes. And this was a very simple way that we could have some ownership of our data and run queries. Then it started to work not quite so well, and we started to run into some problems, which was, as the data volumes grew, and you'll see later how much they grew by, we started to run into some of the same problems around, you wanted to run big analytics queries, they take a long time to run. We're trying to write lots and lots of data, which if you've used a database like Postgres, which is really running transactions, if you've tried to write a huge amounts of data into it, you'll find that it starts to hit performance problems. So we did sort of some of the obvious things that you'll do in a case like that, which is we added a read-only replica for the data. So everything that gets written into that primary Postgres database and goes into a read-only replica, and then we run our analytics queries from there. So the analytics queries we run can't affect the performance of the primary database. We put the writing, rather than writing directly into it from Rails, we put it them into a queue. So if there's a massive spike, that queue just builds up, and then we write them into the database when the database is able to accept that write. And this worked for a little while as well. We ended up running these Postgres replicas. We actually had a server in the office, and we put a bunch of really fast solid-state drives into it, put some NVMe drives in there, and we kind of managed to hack it and keep it working for a while. But it was clear that we were pushing Postgres sort of towards the limits of what it's really good at. It's really great at running transactions, but the analytics work that we were trying to do was pushing it sort of outside of what its wheelhouse was. This is a graph of how our data volumes grew over time. You'll notice if you're eagle-eyed, this graph ends at the start of 2020. No prizes for guessing what happened after the start of 2020, you might remember. But you can see here that we had seen growth up to around 100 million events tracked per week. So we're running pretty high volumes, and we were able to get that to work with a little bit of kind of hacking around and pain on Postgres. But then this thing called COVID might have happened in the start of 2020, and I'll show you now what happened to our event growth over 2020. So that growth you saw at the end now looks absolutely tiny on this, and we went from about 80 million events a week to 1,800 million events per week, or 1.8 billion. So the volume of data that we had to track increased just by absolutely enormously. And absolutely everything broke. So not just across the systems in general, but particularly in the event tracking space. We basically faced a situation where our events database was good enough to collect the events, thankfully. There was a point where I wasn't sure if we were going to be able to collect all the data, but we were able to do that. But the ability to analyze that data was almost impossible, because any query would take far too long to run with the kind of volumes of data we were collecting. And so we clearly needed a different solution, and this is where we went out to say, okay, what are the databases out there that we could run? What are the different solutions we could look at? And we eventually decided that ClickHouse was the best solution. A lot of that was around, we wanted to stick with something open source. We wanted to stick with something that we could run in our development machines. We have a lot of things where we want to be able to test. We want developers who are running the code locally to be able to run the full system, including the data warehouse, so that they can check that data is flowing through correctly and that it integrates correctly with parts of the system that are querying from there, where if we use something that's only cloud-based, that's quite difficult. We saw that ClickHouse had very fast write speeds, and I did actually test a few other systems around this time, sort of different ways of scaling out Postgres, and found that they just didn't have anywhere near the right performance that we needed to handle the enormous volumes of data that we were getting. And obviously the very fast aggregations that we talked about before was a very attractive thing for us. So we went through this process of deciding that, testing a few different solutions, deciding that ClickHouse seemed like it was the one that could handle the kind of data volumes we were at now, and then figuring out how we could migrate, how we could get data in there. A little bit on how that migration went. A lot of the things that were trickiest for us really came down to that very, very free-form nature of the data I talked about before. We had kind of gone for that very simple approach of just writing data completely free-form with JSON columns into Postgres. Where in ClickHouse, you really, really need to be splitting data into separate columns, because the whole nature of the database is columnar. You want to have maybe even a couple of hundred columns in your database, and each column is quite small. So we had to figure out, how do we translate this data that's got a whole lot of big JSON with different values into something that's much wider with a lot of columns, which sounds quite simple, okay, each key just goes into a column. But then you had cases of in one place we use a key to store a string, in another place we use the same key to store an integer. They can't both go into the same column with the same type. So there were things like that we had to figure out how to resolve. This is actually something that he talked about before, about the JSON type. The JSON type would have made our life enormously easier if it was available back then, because it handles exactly this use case of fields that could have different values or could have different types, and handling that in a way that still can store the data very efficiently and store out for very efficient querying. So this is something that would not have been a problem today, but back in 2020 when we did this, that wasn't available, so we had to come up with our own solution. What we ended up building was our own consumer. So we were writing all of our data. We started writing all our events data into Kafka, and then we built our own Java-based consumer that would take the data out of Kafka and store it into ClickHouse. And in that thing, because it was just a Java program that I wrote, we could do a lot of transformations, we could change the data, and we could fix a lot of... We also just had a lot of bad, like, weird data that had been collected over the years, so there was kind of a chance for us to do a lot of fixes to the data and tidy it up a bit before we wrote it to ClickHouse. And you talked before about scaling to 1 billion writes per second. We didn't get quite there, but I did scale that to over 1 million writes per second, which was still pretty crazy. And there was, headroom for us to go further, but that was kind of enough. But that meant that we could, when we needed to ingest the data out of Kafka into ClickHouse, we could do that very, very quickly. And we actually settled on a model where we actually retain all of our history of data in Kafka. So if we want to have a new ClickHouse schema, all we have to do is set up a new ClickHouse database, define the new schema, update our consumer to know about that new schema, and then it can just re-ingest all the historical data out of Kafka into ClickHouse. And because inserts are so fast, you can re-ingest 10 years worth of data in a couple of days. So it's pretty incredible what we can do there. The other thing we had to do was get the data out of Postgres, which was actually probably the hardest part of this project, was figuring out how to get this much data out of Postgres. I could have used PeerDB, but it didn't exist yet, so that would have been very helpful. If you don't know, PeerDB is a company that ClickHouse acquired about a year ago, which has a really, really nice way of getting data out of Postgres. But I had to come up with my own method, which actually is quite similar to how that works, but just much more manual. And we tried sort of all of the off-the-shelf ways of getting data out to Bezium and CDCs for Postgres, and none of them could even remotely handle the volume of data we were talking about. So that was, if you have any questions about that, I can talk more about that, but that was something that we needed to do. So we ended up with a new stat that looked something like this, where we take data from users, we write it into Kafka, ingest that into ClickHouse with our custom consumer, and then we run queries out of that. So I'm going to hand over to CZ now, who's going to talk more about what happened after this and the evolution of how we ended up actually using this data. I can take maybe a couple of questions and then we'll do more questions at the end.
Yeah, one quick question. So you said that you built a custom ingester from Kafka to ClickHouse, but there is a built-in solution for that in ClickHouse. It was not available back then, or you wanted it to clean up your data?
Yeah, so we actually used that inbuilt one for some of the other data, but this data was, it needed a lot of cleanup. And it was, it's a matter of like the way we have to take these sort of JSON blobs, and a lot of values we need to convert, there's some dates we have to fix, and there's certain things where we know that like data recorded in this time period was incorrect, or fields weren't filled in back then. So we do a lot of like fixes like that, which may have been possible to do in a transformation layer, but I spent about a week trying to figure that out, and then I was like, this would be faster just to write a thing in Java with a Kafka library to consume the data and fix it. So that ended up being the solution we went with. Okay, yeah, one more. Thanks.
Yeah, just I guess from memory, what would you say roughly took in between discovering that with the surge of activity and COVID, rely on Postgres going to work and just deciding to try
It's probably about 2 or 3 months. I mean, in this period, we were also trying to fix a lot of other systems, and analytics wasn't kind of the first priority. It was keeping the servers, the production systems running. But once those were relatively stable, it was probably a couple of months to identify ClickHouse as a solution. To say we tried a couple of others as well, so like Citus, which is a Postgres system as well, that it became clear that ClickHouse was the best solution for us, and then a couple of months of migrating and figuring out how to get the the ingestion right and get the data across and things like that. Cool.